You are speaking to Mr. Mutaung BP. Today, the topic that I am going to take you through, it will be analytical geometry. Our focus is going to be on grade 11 analytical geometry as well as grade 12 analytical geometry. I believe and hope that our lesson will be fruitful, and then we shall perform when we get to paper 2. With that being said, let me take the opportunity to start our presentation. Okay, let us move forward now. Our objective, we are going to start with analytical geometry of grade 11. So our objective are, after completing this chapter, learners, you should be able to do the following. You should be able to derive and apply, first bullet, the equation of a line through two given points. We know that for us to be able to determine the equation of a straight line, we need two things, mainly which are the gradient of that line and at least one point that you are going to take and then substitute to find your equation. Bullet 2, the equation of a line through one point and parallel or perpendicular to a given line. We need to remember, before we can dwell much onto it, we need to remember that we are having these two concepts, which are when we have parallel lines and when we have perpendicular lines. We need to know, in terms of gradient, what is happening when two lines are parallel. What is the relationship between those two lines in terms of gradient? And also, what is the relationship between two lines when we say they are perpendicular in terms of gradient? What is going to happen? Then the following bullet, we are going to focus on the angle of inclination as well as the inclination of a line. And then we are going to do what? To derive and apply the equation that defines a circle with radius r and the center A and B. Then from there, we will be in grade 12. Then determining the equation of a tangent to a given second. So the last two bullet, it is now that we are in grade 12. Then the revision formulas from grade 11. My children, we need to remember that we are having our formula sheet. Our formula sheet should be our what? Our friend, should be part of us. But going through the formulas from grade 11, the first one, we are having the distance formula. Other people likes to call it the length. But when we talk of the length, as well as the distance, we are speaking of the same thing. Let us start here. We are having AB squared equals to, if ever we are having 2 points, point A and point B, then what will be our distance formula? It will be AB squared equals to the x coordinate of B minus the x coordinate of A, close bracket, to the exponent of 2 plus, open bracket, the y coordinate of B minus the y coordinate of A, close bracket, to the exponent of 2. Normally, most of us, if not all, some of us, we are used to the one that is below, which is AB equals to the square root. Then inside our square root, we are going to have open bracket, the x coordinate of B minus the x coordinate of A, close bracket, to the exponent of 2 plus, open bracket, the y coordinate of B minus the y coordinate of A, close bracket, to the exponent of 2. So those are the two formulas that will help you in terms of approaching any question that has to do with what? With the distance. Then number 2, midpoint formula. Already we have from grade 11 touched this concept of the midpoint. In simple terms, when we talk of the midpoint, what is a midpoint? It is that center point on your line segment of which it will cut or it will divide your line into two equal parts. So with that being said, let us say we are now given our what? Our line segment AB. We are having our what? Our line AB. So in terms of finding the midpoint of line AB, let us say C, it is the midpoint of line AB. It is the midpoint. So what will be the formula to find the midpoint? XC, looking at our screen, the x coordinate of C, what is it? It is the x coordinate of the midpoint, because why? C, it is our midpoint. So when we look for the midpoint of, when we look for the x coordinate of the midpoint, we'll be saying what? Taking the 2 points that are on our line, which will be point A and B, we'll be saying the x coordinate of A plus the x coordinate of B divided by 2. So that part, my children, it is now when we look for the what? We look for the x coordinate of the midpoint. Then finding the y coordinate of the midpoint. In this case, in front of you, we are having point C, which is the midpoint. And we know that a point has 2 coordinates, which is the x coordinate and the y coordinate. So to find the y coordinate of C, which is the midpoint, which is the y coordinate of the midpoint, we'll be saying what? The y coordinate of A plus the y coordinate of B divided by 2. Such formulas, Banabaga, we need to make sure that in our formula sheet, we familiarize ourselves with them. Going forward, the gradient of a straight line. We say, if given the coordinates of 2 points on the straight line, how do we find the gradient? We say our gradient will equals to, for our example, I use point J and point K. So that means our formula will have to be the y coordinate of J minus the y coordinate of K divide by the x coordinate of J minus the x coordinate of K. What you tend to do, some of you, is that the moment a straight up question comes and say, find the gradient, you tend to make a mistake to say, or at your numerator, your top side, you start with x. No, our formula goes as follows, even indicated on the screen. We start with y. We should move away from saying we'll have x1 minus x2 divided by y1 minus y2. We should move away from that and then stick to our correct formula, which our numerator start with the y's, then our denominator start with the x. Moving forward, and as we speak with the gradient, we are having, they say, if given 2 parallel straight lines, what is happening? We need to remember, my beautiful children, that the moment we are having 2 lines that are parallel, we should know that they share the same gradient. If, for example, I have 2 line segments, I have line segment AB and I have line segment CD, and I know, or it is given, that the 2 lines are parallel, it means that the gradient of line AB will be the same as the gradient of line CD. 2 lines that are parallel, they share the same gradient. The following bullet, we say, if given 2 perpendicular straight lines, what is happening? We are now having the second relationship. It is now when 2 lines are perpendicular. There is this misconception, or is it an error, that the moment we are talking about 2 perpendicular lines, there are learners that tends to say what? 2 perpendicular lines, they have the same gradient. Again, my children, we should move away from that concept, because that concept, it is incorrect. 2 lines that are perpendicular do not have the same gradient. They do not have the same gradient. But what is happening? How do we see 2 lines that are perpendicular? At a point of contact where they touch each other, they form an angle of 90 degrees. They form a right angle. So the moment two lines at a point of contact, they have formed an angle of 90 degrees. We say now two lines are perpendicular. Then in terms of gradient, what is happening? It means the two lines, the product of their gradient should give us what? -1. When I say the product, I am talking about multiplication. So that means if, for an example, I have line AB and line CD, they are perpendicular. It means that when I take the gradient of AB and I take the gradient of CD, I multiply them, they should give me -1. The moment I take two gradient of the two lines and I multiply them and the answer is not -1, then that simply tells me that the two lines are not perpendicular. So that is another concept that we should always familiarize ourselves. Then the following bullet, we say if given the angle of inclination, what do we do, or how do we approach that concept? We know every time when we are expected to find the equation of a straight line, the first thing that comes into your mind is that you must have 2 points on that line segment, then find the gradient using the correct gradient formula, which on your numerator it will be the y coordinates, on your denominator will be your your x coordinate, and then you'll take a point, then substitute in your equation. Some use y equals to mx plus c, some use y minus y1 equals to m, which is the gradient, open bracket, x minus x1 close bracket. But in terms whereby we are not given 2 points, but we are having an angle of inclination. What is an angle of inclination? An angle of inclination, it is that angle formed between the drawn line and the x-axis. We are going to dwell much onto it as we go to the problems. Then our formula to find angle of inclination will be m, which represented the gradient will equals to tan of an angle. Our angle can be beta, our angle can be theta, or our angle can be alpha. Then number 4, the equation of a straight line. You need the gradient and the coordinates of a point on the line, of which I already have talked about. But we know we are having 2 approaches. We can use y equals to mx plus c, or we can use y minus y1 equals to m, open bracket, x minus x1. Then let us continue. If A, B, and C are collinear, then it means the gradient of AB will equals to the gradient of BC. It will also equals to the gradient of AC. Then in that time, we are talking about this concept of what? Collinear points. Collinear points, they share the same gradient. If A, B, and C, they are on one straight line and they are collinear, it means the gradient of AB will be the same as the gradient of BC, and also will be the same as the gradient of AC. Then we are going to dwell much onto our concept as we go forward. Then let us talk about these two, which is the vertical line and the horizontal line. When we talk of the vertical line, it is now that the gradient is undefined. What do I mean by that? I want to say, the moment you have a vertical line, my child, you should not be frustrated and you say, the moment now I am having a vertical line and the gradient is undefined, it means now I will not have an equation. No, you will have an equation. But what is happening is that you see by 2 points that a line is vertical. It's when the gradient is undefined, or number 2, the vertical line must be perpendicular to the x-axis. I repeat again, the vertical line for you to have a vertical line, how do you see it? It's when now the normal procedure to find the gradient of a line, we use 2 point, substitute in our gradient formula, then get the answer. But now, the moment our gradient is undefined, that should tell you, if your calculation, if your substitution is correct, that should tell you that the line is vertical. And number two, how do you see a vertical line? Is that a vertical line must be perpendicular to the x-axis of your Cartesian plane. Then the equation of a vertical line will always be x. X equals to what? X equals to that number whereby your line, your vertical line, will cut the x-axis or will intersect the x-axis. So for example, let us say we are having our vertical line. It cut our axis at 2. It means now that because our vertical line, we see it by the gradient being undefined, and we also see it by what? We also see it by being perpendicular to the x-axis. It means now that the equation will be x equals to 2. Let us do it this way. Here we are having the x-axis, we are having the y-axis. Then roughly so we are having our vertical line, which is AB, and let us say now it is perpendicular. It is perpendicular, it is a vertical line. And therefore, the x coordinate here, the x value here, let us say, for example, it will be 4. Then I say, give me the equation of this vertical line AB. Because now the gradient is undefined. It does not mean now my equation, I don't have an equation. I do have it. What will it be? I look where my vertical line passes on the x-axis. I took 4 as an example. It means now my equation will be x equals to positive 4. Then we go to horizontal line. How do we get to see that we are having a horizontal line? You are having 2 points. What are those 2 points? Number 1, your gradient must be 0. The moment you have used correct formula, I emphasize that when we find a gradient, our formula will be gradient equals to the y-coordinate of a point minus another y-coordinate of a point divided by x. Your x-coordinate should be your denominator. That's where my point is, because, my children, you tend to make a mistake that you take the x-coordinate, you put as your numerator, then your denominator, your y values, your y-coordinate, you put them as your denominator, of which now your formula is not correct. All right. So the moment your substitution and you have used a correct formula, the gradient is 0. That 0, what does it indicate? It indicates that you are having a horizontal line. Then number 2, to see that you are having a horizontal line must be parallel to the x-axis. Let me say I am having a line, roughly so. Let me say I'm having line CD. Nah? Then the moment I'm having line CD, it is parallel with the x-axis. The moment it is parallel with the x-axis, that should tell you that line, segment line CD, it is a horizontal line. Then the moment it is a horizontal line, how do you determine the equation? You should not be scared. You should not be frustrated that now you are getting a gradient is 0. I said what? The moment the gradient is 0, number 1, that indicates you are having a horizontal line, and also your horizontal line should be parallel with the x-axis. Therefore, to find the equation of a horizontal line, it will have to be y equals to the y value. Which y value? On the y-axis, where your horizontal line passes or it intersects. Let us take, for example, that where this line CD passes, we are having 6. The y value there, it is 6. So the moment I ask you, my child, what will be the equation of my horizontal line? You'll have to tell me that, Minier, y will equals to 6. Then that will be your what? That will be the equation of a horizontal line. I repeat again as I'm about to move forward. Remember, when we talk of a vertical line, the gradient is undefined. The moment you have used the correct formula, your substitution, it is correct, and then you get your gradient as undefined. That undefined should not scare you, but to give you an indication that you are having a vertical line. Then number two, a vertical line, how do you see it? It must be perpendicular with the horizontal axis. The horizontal axis that I'm talking about, it is the x-axis. Then number two, a horizontal line. The moment you determine a gradient and you have used a correct formula of a gradient and you have substituted correct, and the gradient is zero, that zero indicates that you are having a horizontal line. And another indication that you should be on the lookout for is that the moment you are having a line segment and it is parallel with the x-axis, just know you are having a horizontal line. Then let us look at this question. At this question, they say in the diagram below, the line joining Q, the coordinates of Q will be -2 and -3, and P, the coordinates of P, it's A and B. Then we are told that A and B it is greater than 0. B, it is greater than 0. Anything that is greater than 0, it means it is positive. Anything that is greater than 0, greater, it means it is positive. Then makes an angle of 45 degrees with the positive axis. I pointed out, okay, I am having what? Okay, sorry. I am having what? Okay. We are told that an angle of 45, it is there with the positive axis. Then QP equals to 7 square root of 2 units. What is QP? That will be the length. That will be the distance, which is 7 square root of 2 units. Then we are having N. The coordinates of N, we are given it is 7 and 1. Then we are told that this point N is the midpoint of PR, and M is the midpoint of QR. Then the first question, 3.1, it says you determine the gradient of what? Of PQ. This question addresses the concept of gradient, because now we are having what? We are having the question that says determine the gradient of PQ. We are going to say, let me write it here, the gradient of PQ, we are going to say the gradient of PQ equals to the y coordinate of Q minus the y coordinate of P divided by the x coordinate of Q minus the x coordinate of P. I emphasize again, my children, that the moment you determine a gradient of a line segment, make sure that your numerator, it is the y coordinates, the difference of the y coordinates, then your denominator, it is the difference of the what? The x coordinates. Then we are going to have what? We are going to say, what will be the y coordinate of Q? We are given that it is a -3 minus the y coordinate of what? Of P. But when we look at the y coordinate of P, both the coordinates of A and B are not given. Therefore, the moment that happens, you see now you get to be scared to say, what is happening? Where are the coordinates of A? Where are the coordinates of B? Do not be scared. Analyze. Then from there, you get to see, okay, I am given 45. Then the moment I am given 45, what is now going to happen? what is now going to happen? We see now that we are given an angle of inclination. An angle of inclination. Our angle of inclination, it is 45. I explain again. What is an angle of inclination? Angle of inclination, it is that angle that is formed between the x-axis and the drawn line. And that will be angle of inclination. So for our QP, we are having angle of inclination. So that will be 45. So we can summarize say what? Okay, for 3.1, because the one of a gradient substituting 2 points does not work because the coordinates of P both are unknown. Therefore, our alternative will be using what? Angle of inclination. So we'll be saying what? We'll be saying tan theta. Let me use theta. Then it will equals to the gradient of what? The gradient of PQ. Then what is our theta? What is our angle in this case? It is 45. That means we'll be saying tan 45 degrees will equals to the gradient of PQ. Therefore, the gradient of PQ will give you what? Tan 45 will give us 1, if I am not mistaken. Yes, tan 45 will give us 1. What that will be the gradient of what? That will be the gradient of PQ. Then the following questions, they say 3.2, the equation of Mn. Determine the equation of Mn in the form of y equals to mx plus c and give reasons. 3.3, determine the length of Mn. 3.4, determine the length of Rs. 3.5, determine the coordinates of S such that PQ RS in this order is a parallelogram. Then the last question, 3.6, determine the coordinates of P. Please take a picture, take note, because I am going to go to a whiteboard. I am not having a sufficient space whereby I can address all these questions. So just take note of the sketch as well as the sketch as well as the question. Okay, I will reread our statement as we begin. They say in the diagram below, the line joining Q, -2 and -3, and P, A and B, B is greater than a 0, makes an angle of 45 degrees with positive axis. That is an angle of inclination, because the definition of angle of inclination is that angle of inclination, it is the angle formed between the x-axis and the drawn line. Then that drawn line will become the line of inclination. Then they say QP equals to 7 square root of 2 units. And the coordinates are 7 and 1. Then it is the midpoint of PR, and M is the midpoint of QR. Because now we already have addressed 3.1. We come to 3.2, which requires the equation of Mn. The equation of Mn. Okay, so to find the equation of Mn, we know that the standard form of the equation of a straight line should be in the form of y equals to mx plus c, where m represent what? The gradient. So now, let us look now. We are given that Pn, it is equals to Nr. Then we are also given that Qn, it is equals to Mr. Shortly, let me draw the sketch. Let me draw our sketch. Then we are having PR. It's chrome this one. It's chrome this one. It's not good. But roughly you can see. I will try my all best to have a clear sketch. Then we are having the x-axis. We are having 45 degrees, which will be point T. We are having Q. The coordinates of Q is -2 and -3. Then we are having M. We are having point M. This side equals to this side. We are having point R over here. We are having P. The coordinates of P is A and B. They are known. Then we are having point S. There we are. I hope I am not missing anything. I'm not leaving anything behind. Okay. So from 3.1, we know that the gradient of PQ, from 3.1, we know that the gradient of PQ is equals to 1. We got it by using angle of inclination. So to get the equation of MN, we need to go back in grade 10. Grade 10 when we were talking about the midpoint theorem. Grade 10 when we were talking about the midpoint theorem. In summary, what was midpoint theorem say? It was saying, I will use this example. The moment Pn, it is equals to Nr, and Mr, it is equals to Qp. It means these two sides that are opposite to each other will be parallel to each other, meaning Mn will be parallel to what? Will be parallel to Qp. And what will be our reason? Midpoint theorem. It means now the gradient of PQ will be the same as the gradient of Mn. Why is that? Is because of midpoint theorem. That midpoint theorem, where did we learn it? From grade 10. Therefore, it means now that the gradient of Mn, the gradient of Mn will also equals to 1. Then from there, where are we going? We are going to go to y equals to. The gradient of Mn is 1. So we are going to have x plus c. Don't be surprised to ask, Hore, where did 1 go? The 1, it is the coefficient of what? Of x. If the gradient was -1, then we were going to have what? Negative x. Then we know the procedure, the standard procedure is that the moment we have the gradient, we must find a point that is on the line that we are looking for the equation of it. We are going to substitute where we see x and y to find the value of c. So we are having point N, which lies on our line MN. 7 represent the x coordinate, 1 represent the y coordinate. So we are going to have 1 equals to where we see x, we substitute 7 plus c. We want c, not 7 plus c. So what are we going to do? We are going to transpose 7. Then we are going to have 1. The moment we transpose our 7, before it is positive, the moment we transpose it becomes negative, equals to c. Then the value of c will be 1 minus 7. It will give us -6. Therefore, our equation of Mn will be x minus 6. Others, they prefer this method of y minus y1 equals to m open bracket x minus x1. The first thing that we do, what do? We substitute our gradient. Yes, our gradient will be positive. 1. Do not be surprised if I did not write it. It's a positive 1, therefore it's there. So to go forward, remember the standard procedure, a gradient as well as a point that is on that line. So we are having point N that is known. So 7 represent the x coordinate, 1 represent the y coordinate. So y1 and x1, it is where you are going to substitute that point that you are having from your diagram. So we are going to have what? Y minus 1 equals to 1, which is your gradient, open bracket, x minus x1, it is the x coordinate of point N, which is 7. Then we are going to have y minus 1 equals to, because now let us look, 1 multiplied by the bracket of x minus 7. It will not make such a significant difference. So we'll still have what? X minus 7. We know, my children, that our equation must be in the form of y equals to mx plus c. So we need to simplify it now. The moment we simplify it, what are we going to do? Take -7 to the -1, to the right hand side. -1 and -7, they are like terms. So we are going to be left with y equals to x minus 7. Your -1 on your 1 on the left was negative. The moment you transpose, never make a mistake and you say it will still be -1 when it arrives on the right. But you have to change a sign. We'll have a positive 1. Therefore, y will equals to your equation. Therefore, y will equals to x minus 7 plus 1. -7 plus 1, you press in a calculator, it will give you -6. Therefore, your answers are the same. And my advice is stick to what works for you, my child. Then let us go to 3.3. 3.3, it was saying determine the length of mn, the length of mn. All right. Let me write Antlemo mn. Okay. Let us go back on our sketch banabak. We are given that Pn, it is equals to Nr. And we are given that Mr, it is equals to Qm. That means now Nm will be parallel to what? To PQ. From where? From what? From grade 10 midpoint theorem. So we are looking for what? We are looking for Mn. Let us remember from our sketch, not from our sketch, I'm sorry, but from our statement, we were told that QP is equals to 7 square root of 2 units. So that means now you are going to say what? We are going to say to find Mn, we are going to say Mn will equals to the half. The half of what? The half of, I'm sorry, I wrote QR. Sorry about that. I wrote QR, not QR, but QP. Okay. So going back to the question, we say Mn will equals to the half of what? The half of QP. You need to have a reason. Your reason, remember, we are talking about what? Lovely things, which is midpoint theorem. From where? From grade 10. Okay. Then we are going to substitute. We say the half of what? Of 7 square root of 2. Then our answer will have to be half multiplied by 7 square root of 2. Our answer will be 7 square root of 2 divided by 2, or because we are not restricted, we are not told leave your answer in a set form or leave your answer as your decimal. Our answer will be also 4,95 what units. I hope we are all right. Then let us go to 3.4. Allow me to write it over here. 3.4, it says, determine the length of RS. Determine the length of RS. Good people, we are having a sketch in front of us. Our sketch in front of us, that will be what? That will be PQRS. PQRS, it is a parallelogram. We are having a what? A parallelogram. Therefore, it is very, very, very important that in analytical geometry, my children, you should know, at the back of your mind, you should know the properties of each quadrilateral, because what you'll come across is that in your question paper, in a test, in a classwork, your teacher will give you a question of analytical geometry that is talking about a certain quadrilateral from grade 10. Each quadrilateral, you must know its properties, starting with trapezium. We are having a square, we are having a rhombus, we are having a parallelogram, we are having a rectangle, we are having a kite. Those quadrilaterals, you must know the properties. You must know the properties, because now PQRS is a parallelogram. The moment it's a parallelogram, at the back of your mind, you should remember the properties. What are the properties of a parallelogram? We know that opposite sides are parallel and equal. Opposite sides are parallel and equal. Both pairs of opposite sides are parallel. Both pairs of opposite sides are equal. Both pairs of opposite angles are equal. Then the diagonals bisect each other. So in answering 3.4, the question in a determine the length of RS is because RS is equals to QP. Why? Because we know from grade 10, both pairs, or we can say that opposite sides are equal. And you should remember, we are talking about what? We are talking about a parallelogram. And remember, we were told that in our statement, QP is equals to what? 7 square root of 2. That means also RS will equals to 7 square root of 2 units. And for you to be able to attempt and get correct of this question, you must go back to grade 10 and know the properties of each quadrilateral. It is your responsibility. Your respective teachers have taught you from grade 10 the properties of each quadrilateral. My advice is that go back to textbook of grade 10 or even grade 11. Look for that page that has stipulated every property of each quadrilateral. Copy that page, paste it in your fridge or in your door. Every time when you go to school, every time you come back from school, you see those properties, you seeing those properties, you know those properties. You must know the properties of each quadrilateral as much as you know who you are, as much as you know your name. Thank you. Let me move forward. Then let us go to 3.5. Our 3.5, our question, it was saying we need to determine the coordinates. Sorry for my beautiful handwriting, sorry. The coordinates of S such that PQRS in this order is a parallelogram. The moment you hear the word parallelogram, just remember what? Before you can attempt your what? Your question, Remember. You are given a what? A parallelogram. You must do what? Remember. Remember what? The properties of a parallelogram. Both pairs of opposite sides are parallel. Both pairs of opposite, let's do it like this. Both pairs of opposite sides are parallel. Both pairs of opposite sides are parallel. Both pairs of opposite sides are equal. Are equal. Again, now, then both pairs of opposite angles are equal. That means angle Q will be equal to angle S. Angle P will equals to angle R. Then what also do we know is that the diagonals bisect each other. It means now, let me do this. Let me erase this red pen. Okay. Or we can do it in this way because my what? My sketch is not drawn to scale. Let me try to write it in this way. Okay. What do we know about a parallelogram? The diagonal bisect each other. What does that mean when we say the diagonal bisect each other? It means now Pn will be equals to Nr as well as Qn will equals to what? Qn will equals to NS. We should be aware of that. Then that means now, if Qn is equals to NS, it makes point N the midpoint of QS. And also, because the property of a parallelogram says the diagonal bisect each other, it means Pn, since Pn is equals to Nr, it is also means what? N will be the midpoint of what? Will be the midpoint of PR. And in conclusion, what does that tell you? It tells you that N, it is the point of intersection for the two diagonals, for the two lines, QS as well as what? PR. Because N, it is the midpoint of QS, and P and N, it is also the midpoint of PR. It means the two diagonals, they share the same gradient. Then let us look now. What is given? We are given that N is the midpoint of what? Of PR. We were told that. And M is the midpoint of, okay, let us leave M. Okay, N is the midpoint of PR. It also means that N will be the midpoint of what? Of QS. What is given, my children? We are given the midpoint. You know, to make mathematics easier, you work what is given to find what is not given. You use what is given to find what is not given. All right, let us look. What are we given? We are given this beautiful point, which is point N. The coordinates of point N is 7 and 1. And we are also, let us shift our focus and focus on line QS. On line QS, we are having 2 points. The first one I have indicated, that is the midpoint. Then we are given the what? The coordinates of Q, which is -2 and -3. What is given? The midpoint of what? Of line QS. So to find the coordinates of S, you use what is given to do what? To find what is not given, which is the coordinates of what? Of S. How are we going to approach this question? We are going to say, all right, because I am given the coordinates of N, which is the midpoint. If I was not given the coordinates of N, which is the midpoint, but I was having the coordinates of S, then I was expected to find the midpoint. It means I was just going to say the X coordinate of Q plus the X coordinate of S divided by 2. The Y coordinate of Q plus the Y coordinate of S divided by 2, then I will have found the coordinates of what? Of the midpoint. Because now I have it, it means now that the X coordinate of N It is what? The x-coordinate of the midpoint. Standard, basic. How do we find the midpoint? We know that to find the midpoint, we must have 2 points. In this case, we are focusing on line QS. It means we will be saying the x-coordinate of Q plus the x-coordinate of S divide by 2. So if we did not have N, we did not have the coordinates of N, they were unknown, and I had the coordinates of S, it means to find the coordinates of N for the midpoint, I was just going to say the x-coordinate of Q plus the x-coordinate of S divided by 2. But because now I have them and I have the x-coordinate of N, I say the x-coordinate of N. To find it, I say the x-coordinate of Q plus the x-coordinate of S divided by 2. Then I go again, I say the y-coordinate of N will equals to the y-coordinate of Q plus the y-coordinate of S divide by 2. Then I go and substitute. What is the x-coordinate of N? That will be 7. 7 will equals to the x-coordinate of Q is -2 plus the x-coordinate of S. Do I know the x-coordinate of S? I don't have it. I'm looking for it. So it will be my variable x-coordinate of S. Divide by what? Divide by 2. Do I have the y-coordinate of N? Yes, it is 1 equals to. Do I have the y-coordinate of Q? Yes, it is -3 plus. Do I have the y-coordinate of S? No, it is my unknown. Therefore, I'm going to put it as it is, the y-coordinate of S. Divide by what? By 2. Then from here, to make our simplification much easier, put 7 over 1. Then I do what? I apply cross multiplication. 2 will multiply 7. It will give me 14 equals to 1 will multiply -2 plus the x-coordinate of S. It will not make much of a significant difference. So we will also be left with -2 plus the x-coordinate of S. We apply the same procedure on the y's. We put 1 over 1. Then we make a nice cross multiplication. 2 multiplied by 1. That will give us 2 equals to 1 multiplied by -3 plus the y-coordinate of S. It will be -3 plus the y-coordinate of S. Then from there, we are having algebra. We are just solving. I am looking forward for the x-coordinate of S, but I am being disturbed by -2. What am I going to do? Take -2 to the other side. It is -2. So when I take it to the other side, it changes the sign. It becomes positive. So I have what? 14 plus 2 equals to the x-coordinate of S. I do the same approach. -3, I transpose it. It will be 2 plus 3 equals to the y-coordinate of S. Therefore, before we can say therefore, 14 plus 2, it will give us 16 equals to the x-coordinate of S. 2 plus 3, it will give us 5, which will be the y-coordinate of S. Therefore, now, we can say now what? The coordinates of S. It will be what? It will be 16 and 5. And how do we see that we are correct? We are having our Cartesian plane, my children. And most of our sketch, it is in the first quadrant. What do we know in the first quadrant? We know that the x values, they are what? They are positive. The y values, they are what? They are positive. The values on the x-axis, they are positive. The y values on the y-axis, they are also positive. And we got that the x-coordinate, it is 16. The y-coordinate, it is 5. Both of them are positive. Therefore, I would like to believe that we are still on the right path. Ne? All right. I want us to go to the next slide. Thank you. All right, let us move forward. Okay, there we are. Okay. Therefore, let us look for this last example. Then I want us to go and do nice things, which is grade 12 analytical geometry. Analytical geometry. Okay, let us look at this question. This question, what does it say? It says A, the coordinates of A is 1 and 6. The coordinates of B is 3 and 0. The coordinates of C is 12 and 3. And D are the vertices of trapezium with AD parallel to BC. The moment, my children, I hear two lines that are parallel, what comes into my mind is that the two lines, they share the same gradient. Two lines that are parallel share the same gradient, but two lines that are perpendicular, they do not share the same gradient. They do not share the same gradient. But what happens? The product of the two gradients of those two lines equals to -1. That's when we are talking about what? Perpendicular lines. Okay, let us continue. Then we are told that E, it is the midpoint of what? Of BC. Then we are having what? The angle of inclination. I love angle of inclination. What is angle of inclination? It is the angle that is formed between the what? The x-axis and the drawn line. For example, you cannot say that angle D. You cannot say that angle D, it is angle of inclination. Is it between the x-axis and the drawn line? No, it is not. Your angle, its base should be what? Should be the x-axis. Its base should be the x-axis. Okay. Then we are told that the angle of inclination of the straight line BC is theta, as shown in the diagram. I want us to address the following concept, and then we go forward. Okay, they say calculate the coordinates of E. To make things easier, Banabaga, it is not always that you need to be frustrated. You think that maths is difficult. Maths is one of the easiest subjects. You need to listen and be consistent with practicing. So, we use what is given to find what is not given. We are told that E is the midpoint. So, you get a what? An indication. You get a what? A direction. Or, okay, E is the midpoint. How do I normally find the midpoint? On that line, I must have 2 points that I am going to use, substitute, then find my what? My answer. Okay, when I see point E lies on line BC. And we are told that BC, E, it is the midpoint of BC. So we are going to say what? We are going to say for 3.1, we are going to say the midpoint of BC will equals to open bracket the x coordinate of B plus the x coordinate of C divided by 2, the y coordinate of B plus the the y coordinate, sorry about that, the y coordinate of C, then divide by 2, close your bracket. Then let us now go and substitute. Open bracket. What is the x coordinate of B? That will be 3. We are going to have 3. Sorry for that. For my beautiful handwriting. We are going to have 3 plus. What is the x coordinate of C? It is 12. Divide by 2. What is the y coordinate of B? It will be 0 plus. What is the y coordinate of C? That will be 3. Divide by what? Divide by 2, close bracket. That means, therefore, the coordinates of E will be what? 3 plus 12 give us 15. 15 divided by 2 will have 15 divided by 2. Then 0 plus 3 give us 3 divided by 2. That will be 3 over 2. That's how we do it. We do find the midpoint. We do find the midpoint. Okay. Let us go to the next question. The next question, it says 3.2, determine the gradient of line BC. This one, it is very, very, very straightforward. Finding the gradient of BC. Okay, why am I saying it's very, very easy to find? Is because I have the coordinates of B, I have the coordinates of C. So I can, so Martlar do what? Go to my formula. My 3.2, I am going to say what? The gradient of BC will equals to what? The y coordinate of C minus the y coordinate of B, divide by the x coordinate of C minus the x coordinate of B. I repeat again, my beautiful children, is that to make things easier for you, you have a formula sheet. You have a formula sheet. Yes, it is good to know a formula by heart, but to verify that you are writing a correct formula, go to your formula sheet. Your formula sheet should be your best friend, not that best friend who lies to you. Formula sheet will not lie to you, but it will give you the truth. Okay, let us go forward. What is the y coordinate of C? The y coordinate of C, I see that it is 3 minus the y coordinate of B, it will be 0. Divide. What is the x coordinate of C? The x coordinate of C will be 12 minus. What is the x coordinate of B? That will be 3. Then our answer, the gradient of BC. Let us look at it. Did we substitute correct? Did we substitute correct? The y coordinate of C, it is 3, yes. The y coordinate of B, it is 0. The x coordinate of C, it is 12. The x coordinate of B is 3. So 3 minus 0 is 3. Then 12 minus 3, it will give us 9. So we are going to have 3 over 9. If I'm not making a mistake, 3 over 9, it will give us 1 over 3. Please verify it for me. If 3 over 9 do give us 1 over 3. 3 over 9. Yes, 3 over 9 give us 1 over 3. Beautiful. Then we go to 3.3. Allow me to write it over here because we are having a nice space. Okay, 3.3. Calculate the magnitude of theta. What is theta? Theta is the angle of inclination between what? Between line BC and the horizontal axis, which is the x-axis. And it makes line BC becomes what? Becomes the line of inclination. Because now we have the gradient of BC. What can we say? To find the gradient, to find the magnitude of theta, we are going to say what? We are going to say tan. Tan what? Tan theta equals to the gradient of what? Of line BC. Why BC? Why not AD? Why not AB? Why not DC? Because BC, it is the one with the x-axis that has formed the what? The angle of inclination. Then we get to call it what? The line of inclination. BC becomes our line of inclination. So we are going to say what? We are going to say tan theta equals to the gradient of BC, we got it, which is 1 over 3. Then to get our theta, we are going to apply what we call, other people, they say it will be tan inverse. Other people, they will be say it is tan arc, but there is the same thing. So we are going to say theta will equals to tan inverse of what? Of 1 over 3. Then our theta will equals to what? We press our calculator, tan inverse of 1 over 3. It will give us what? 18,43 degrees. That will be our what? That will be our answer. And when I look at my sketch, I see that theta, it's actually an acute angle. And when I look at what I got, 18 3.43. It is an acute angle. When we talk of an acute angle, we need to remember that an acute angle, it is an angle that is formed, it is an angle that is between 0 degrees and 90 degrees. Then we come to the last question, which is 3.4. They say prove that AD is perpendicular. AD, it is perpendicular to what? To AB. All right, good people. We know that for us to know that two lines are perpendicular, what must happen? We must have the two lines, we must have their gradients. When we multiply their gradient and the answer is -1, is that -1, then it tells us that the two lines are what? Are perpendicular. But now we must find the gradient of AB, or we must have the gradient of AD as well as the gradient of what? Of AB. What I said before, I will say it again. My beautiful children, go back to grade 10. Know the properties of each quadrilateral. We were told that we are having a trapezium. So the moment you hear the word trapezium, or you hear the name of a certain quadrilateral, at the back of your mind you should know the properties of that specific quadrilateral. So because we are having a trapezium, what are the properties of a trapezium? We remember that one pair of opposite side is parallel, meaning, and we are told by our sketch, we are told that AD, it is parallel to what? To BC. So that means because we are told that AD is parallel to BC, it means the gradient of what? Of AD will be equals to the gradient of BC. Why? You don't make your own story, but you need to have a supporting reason. It's because what? It's because we were told that AD, each word is parallel to BC, and we know that two lines that are parallel have the same gradient. They share the same gradient. Okay, so because now the gradient of AD is the same as the gradient of BC, it means now the gradient of AD will equals to 1/3 as well. Then we go now and find the gradient of AB. To find the gradient of AB, am I having the coordinates of A, the x coordinate and the y coordinate? Yes. For point B, am I having both the coordinate x and y coordinate? Yes, I can go to my gradient formula with an open heart. I'm going to say what? I'm going to say the gradient of AB will equals to the y coordinate of B minus the y coordinate of A divided by the x coordinate of B minus the x coordinate of A. Then I substitute now. What is the y coordinate of B? That will be 0 minus what is the y coordinate of A? That will be +6 divided by what is the x coordinate of B? That will be 3 minus what is the x coordinate of A? That will be 1. Then from there, I get my answer to say 0 minus 6, that will be -6. Divided by 3 minus 1, that will be 2. -6 divided by +2, that will give me -3. Then I am not done answering the question. The question say prove that AD is perpendicular to AB. To prove that AD is perpendicular to AB, it means I must have the gradient of AD, I must have the gradient of AB. Then I multiply the two. Then if the answer is -1, it means that the two lines are what? Are perpendicular. So let us go. We are going to say what? We are going to say now the gradient of AD multiply by the gradient of AB. You don't say equals to -1. No. Why am I saying that? Because the moment you say equals to 1, -1, you are giving an impression that already you have proven. But we are still in the process to prove whether the two lines are perpendicular. You don't say they are equals to -1 because we don't know yet whether they are perpendicular or not. Therefore, the next step we substitute the gradient of AD. What is the gradient of AD? It is 1/3. Multiply. What is the gradient of AB? That is -3. Therefore, 1/3 multiplied by -3, you press in the calculator, is -1. Then that -1, what does it tell you? It tells you that AD is perpendicular to what? To AB. You can nicely, with confidence, conclude that AD, it is perpendicular to what? To AB. See how easy it is to pass paper 2. We must make sure that we listen in class, and we must make sure that we practice, and we practice consistently. Then that consistency will give us results. Okay, thank you. Then let us move forward. Let us go to grade 12, analytical geometry. Okay. What are our objectives with the grade 12 analytical geometry? Is that bullet 1. After completing this chapter, you learners, you should be able to derive and apply the equation that defines a circle with radius r and center A and B. What will be A and B? That will be the coordinates of the what? Of the center. Then the key concepts. Completing the square. Completing the square. So, if we are now having the equation of a circle in a form of x squared plus kx plus y squared plus my plus n equals to 0, to move it to be in a form of open bracket x minus a close bracket to the exponent of 2 plus open bracket y minus b close bracket to the exponent of 2 equals to r squared, we complete the square. Let us remember, completing the square, where did we actually learn it? We learned it from where? From grade 11. From where? From grade 11. Okay. Then bullet 2, the following bullet, simultaneous equations, algebra, paper 1, question 1. Simultaneous equation. In this topic, analytical geometry, normally this simultaneous equation, where are we going to integrate it? Where are we going to use it? We are going to use it especially when we are required to find the point of intersection. What is happening in the point of intersection? Point of intersection, it is that point whereby the two functions, they do what? They intersect. The two functions, they do what? They cross each other. The two functions, they do what? They touch each other. Then, following bullet, we are also going to learn to determine the equation of a tangent to a given circle. Okay, a tangent to a circle is perpendicular to the radius at each point of contact with the circle. Meaning, okay, then we say note that because we are saying the tangent will be perpendicular to the radius. The moment a radius, it is perpendicular to the tangent, it means at a point of contact, the two lines, they form an angle of what? Of 90 degrees, right angle. Okay, note that the gradient of a tangent multiplied by the gradient of a radius is equals to -1. To have that -1, it is when now that what? The tangent and the radius, they are what? They are perpendicular. Then the last bullet, a tangent is a straight line. we know that a tangent is a straight line. And the equation of a straight line must be in the form of what? Y equals to mx plus c. Y equals to mx plus c. That is the standard form of a what? Of the equation of a what? Of a straight line. In this case, which straight line are we talking about? We are talking about a tangent. Okay, let us move forward. Example 1. Example 1, it says, determine the coordinates of the center and the length of the radius in each of the following. My beautiful children, please, 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 I am going to emphasize on the following. R squared and radius, they are not the same thing. I repeat again, R squared and radius, they are not the same thing. Okay, let us move forward now. Okay, the question says we need to determine the coordinates of the center and the length of the radius of each of the following. Let us remember the standard form of the equation of a circle. The standard form of the equation of a circle. It says the standard form should be what? Should be x minus a, close bracket, to the exponent of 2, plus, open bracket, y minus b, close bracket, to the exponent of 2 equals to r squared. My emphasis, okay, r squared and radius, they are not the same thing. I am still going to dwell much onto it. Okay, let us look at A. A, we are having x squared plus y squared equals to r squared. But where now you are used to say, okay, the standard form should be x minus a, open bracket, x minus a, close bracket, to the exponent of 2, plus, open bracket, y minus b, close bracket, to the exponent of 2 equals to r squared. But now you have x squared plus y squared equals to 36. And now you get scared. Now you say, oh, this is not making sure. It is still making sure. How so? The moment you are alone having x squared, alone having y squared, you just know that the coordinates of the center are what? 0 and 0. It means now to get x squared plus y squared equals to 36. It comes from where? From x minus 0, close bracket, to the exponent of 2, plus, open bracket, y minus 0, close bracket, equals to 36. Then x minus 0, it is what? It is x. X to the power of 2 gives you x squared, plus, sorry for my beautiful handwriting, is beautiful, x minus 0. X minus 0, it is x. To the power of 2, it is x squared. Then we go forward, y minus 0, it is y. Y to the power of 2, it is y squared, equals to 36. We are having the same thing. Then, in answering the question for A, what will be the coordinates of the center? The coordinates of the center, the coordinates of the center will be what for A? The coordinates of the center for A will be what? Let us hurry more. We are saying for the center, the coordinates will be what? Will be 0 and 0. Then the radius of a circle, the radius of each of the following circle, 36, it is r squared. Okay, 36, it is r squared. R squared equals to 36. Then to get r, it is our radius. R, it is our radius. So to get r from r squared, we are going to do what? Apply. Okay. What's happening now? Okay, let us do this. Let us do this. Okay, our r squared equals to 36. To get our r, we are going to do what? Apply square root. both sides. The square root will do what with the exponent 2? They will fight and cancel each other, will die together. Then you are left with r equals to the square root of 36. That will give you what? 6. That means the radius, which is r, it will be 6. Then let us go to B. B, we are given our equation of a circle, S open bracket x plus 3 close bracket to the exponent of 2 plus open bracket y minus 2 close bracket to the exponent of 2 equals to 32. Then from there, what are the question said we must determine the coordinates of the what? Of the center. And the what? And the length of your what? Of your radius. Isn't so? So that means now, for you to determine the coordinates of the center, remember my beautiful children, we are saying the standard form. Let's go back to the standard form. Our standard form, it is x, open bracket, x minus a, close bracket to the exponent of 2, plus open bracket y minus b, close bracket to the exponent of 2 equals to r squared. We must remember that for you to have positive 3, to have negative 2, what happened? We say, remember when we substitute, we'll have our open bracket x minus. For you to have a positive 3, only negative 3, only negative, you need to remember, okay, negative by negative, it will give you what? It will give you positive. So we are going to have y plus y, then we have a negative 2. Remember, initial from your standard form, you have a negative sign. Your 2 is one, a positive. When you substitute it, close bracket to the exponent of 2 equals to 32. Then when you simplify what I just wrote, it is now that it will give you what? It will give you x. Negative by negative, it will give you what? Positive 3 to the exponent of 2 plus open bracket negative multiplied by positive 2 y. I'm sorry, let me fix that. Y minus 2 close bracket to the exponent of 2 equals to 32. That means now that should tell you that the coordinates of the center, is what? It is negative 3 and what? And positive 2. We are not done in answering the question. The question say what? Say, okay, also the radius. I emphasize again, my beautiful children, that r squared is not the same as r. I know sometimes you can feel overwhelmed when you write paper 2, you get frustrated and all of that. But keep your composure, keep your calmness. What do? You remember, okay, r squared and the radius, they are not the same thing. So if I have r squared, in this case, it is equals to 32. To get the length of the radius, it means I am to get rid of the exponent 2. I am going to apply the square root both sides. Remembering the principle in maths that if you have an equation, what you do on the left, you must also do what? You must also do on the right. So that means the square root of 32, our r, the square root of 32, it will give us 4 square root of 2 units. See how lovely it is. You must not do what? Get analytical geometry wrong. You must excel. Okay, then let us look at example 2. Example 2, we say, determine the coordinates of the center and the length of the radius of each of the following. But now, what is the difference now between example 1 and example 2? It is now that the form of A and B in example 2 is no longer the same with what? With A and B in example 1. Because now we are seeing what? We are seeing, no man. This one is not making sure. We are now having x squared plus y squared minus 6y minus 55 equals to 0. And then I have b still in the same form as a icon. Now I want what? I want open bracket x minus a close bracket to the exponent of 2 plus open bracket y minus b close bracket to the exponent of 2 equals to r squared. That is the form that I want. That is the form that I know. Do not be scared, my beautiful child. You just need to remember the moment I am giving it in this form, I need to remember God, take me back to grade 11 completing the square. You must remember of completing the square. Okay. So, in completing the square, what is happening, my beautiful children? It is that you must have, the moment in your equation you are having two variables, the same way as a and b, you must make sure that, let us look for a and b. I'm having two variables, x and y. So the moment I say, okay, I'm having two variables, I must go to each variable. I must go to a variable that has the exponent of what? Of 1. Not 2, but 1. When I look at a, kinali x squared plus y squared minus 6y minus 55 equals to 0. Which variable has an exponent of 1? It will be y. So it will be y. Y, whereby its coefficient is negative 6. Then when we go to b, we go to variables of which their exponents are what? Are 1. What is the exponent of x? It's 1. What is the exponent of y? It's 1. That is where our focus should be in terms of doing what? In terms of completing the square. Let us go now. For a, am I having x to the exponent of 1? No, x to the power of 1. X to the power of 1. For a, am I having it? I am not having it. So that means I am going to proceed to say x squared, then plus y squared minus 6y. For y, am I having a variable to the power of 1? Yes. Which one? It is y, whereby its coefficient is negative 6. Therefore, I start to complete the square. How do I complete the square? I look at the coefficient of the power that has the exponent of 1. I look for the power that has an exponent of 1, which is y. What is the coefficient of y? Negative 6. I am going to say plus, open bracket. That coefficient, I take it, I say negative 6, divide by 2, close bracket to the power of 2, minus the same thing, open bracket, negative 6, divide by 2, close bracket to the exponent of 2, minus 55 equals to 0. Then I go, I say x squared plus y squared minus 6y. I simplify my first two my first two bracket. Negative 6 divided by 2 gives me negative 3. Still inside the bracket to the exponent 2, it will give me what? Positive what? Positive 9 minus 9 minus 55 equals to 0. Because for the variable x, we did not have x which has an exponent of x. We'll proceed normally. We are not going to do much. But for y, we were having a what? A y as a variable to the exponent of 1. Therefore, what are we going to do now? We are now going to say, okay, because I have completed the square, I am going to focus on the what? On the first 3 terms. Y squared minus 6y plus 9. I focus on those first 3 terms. Then what am I going to do? I am going to do that lovely thing that we know from where? From grade 10, which is factorization. We are going to factorize. So what are we going to do? We are going to continue. We are going to continue saying, oh, sorry. Let me change the color. Okay. We are going to say what? We are going to say x squared plus. We factorize the first three terms, the one that I have highlighted. We are going to say what? We are going to open two brackets. Then we say what? What are the factors of y squared that when I multiply them, they'll give me y squared? It will be y and y. Then I go to the last term. I say, what are the two factors that when I multiply them, they will give me 9, which is the last term. But when I add or subtract them, they will give me -6. It will be 3 and 3. Then now we determine or no, the signs now, how are they going to be? We say, okay, to have 9, it must be +3 multiplied by +3. Okay. But to have -6, I must have -3. -3. -3 plus -3, it will give you -6. Then we do what? Then we say -9. Then we say what? We say -9 minus 55. -9 -9 minus 55, it will give us -64 equals to 0. Okay, then from here, what do you see? I have x squared plus. I am having two identical brackets. Two identical brackets it's in. You can write as one bracket, but the moment you write it as one bracket, remember to put what? Your exponent 2. That means you are going to have what? Y minus 3, close bracket to the exponent of 2. Then what do we do with 64? We transpose. It was negative. Once you transpose, it becomes positive. Then we are now having the equation. We are now, sorry about that. We are now having the equation of a what? Of a circle. Then we can now do what? Determine the coordinates of the center as well as what? The length of the radius. What will be the coordinates of the center? We say the coordinates of the center will be what? Will be 0 and because you are having a -3. Remember, for you to have a -3, it's what? It's negative multiplied by positive. That means I'm going to have what? +3, because +3, the moment you put inside the bracket, it meets with that negative. Negative multiplied by +3, it will give you this -3. Then to get the length of the radius, we are going to say what? We take r squared. 64 ke r squared. We need to remember 64 ke r squared. R squared, it is our what? It is our 64. So to get our r, which is the radius, we are going to apply the square root both sides. The square root and the exponent 2, they are going to fight up until they kill each other. Then we are left with r equals to the square root of 64. That will be 8. 8 what? 8 units. Then now we have what? We have found the coordinates of the center, as well we have found what? The radius, the length of the radius. Together with b. B, we are still going to do what? We are still going to apply the what? The same procedure. We are going to do what? We are going to still apply the same protocol. We are still going to do that. So, very quickly, how are we going to do that? Let us look. We say, okay, where are we focusing? We are focusing on a variable that has an exponent of 1, not 2, but 1. Okay, when I look here, I see, okay, I can put my equation handle is going to be x squared plus 2x plus y squared plus 4y equals to 11. Why am I doing this? I am doing this so that the moment I complete the square, you can see, or okay, this part, this portion, it is the variables of x. This portion, it is the variables of what? Of y. Then once we have identified, okay, here I have the variables. whereby the exponent is 1, I look at their coefficients. I look at their coefficient. This is what I am talking about. We are going to focus on 2x. We are going to focus on 4y. For us to do what? To complete the square. We are going to say what? We are going to say, okay, x squared plus 2x plus, I now introduce completing the square. I take the coefficient of x. What is the coefficient of x? Is 2. I am going to have 2 divided by 2, close bracket, to the exponent of 2, minus the same thing, open bracket, 2 divided by 2, close bracket, to the exponent of 2. Then I am done with the variable of x. I come to y. I'm going to say y squared plus 4y plus, I take the coefficient of that variable that has an exponent of 1, which is what? Y. Y has an exponent of what? Of 1. What is the coefficient of y? That will be 4. I say open bracket, 4 divided by 2, close bracket, to the exponent of 2, minus 4 divided by 2, close bracket, to the exponent of 2, equals to 11. Then from here I simplify. I'm going to have what? X squared plus 2x plus 2 divided by 2, it is 1. To the exponent of 2, it will still give me 1. Minus 2 divided by 2, it is 1. 1 to the power of 2 to the exponent of 2, it still gives me 1. Plus y squared plus 4y plus 4 divided by 2, it is 2. To the exponent of 2, it is 4. Minus 4 equals to 11. Then from here, what are you going to do? Your focus now, it goes to what? It goes to the first 3 terms. First 3 terms of what? Of each variable. The first 3 terms of each variable. How many variables do I have? I have 3. We have 2 variables in this equation, which is x and y. So what are we going to do? The first 3 terms of each variable. So for x, the first 3 terms of x, the first 3 terms globally in, we are going to have x squared plus 2x plus 1. Then we come to y. We are going to have y squared plus 4y plus 4. There we are. Then what are we going to do with those? We are going to do what? To factorize those 2. What are we going to do? -1 and -4. Transpose them to the other side. I'm going to be left. Sorry. I am going to be left with what? With what is happening now? -1. We are okay. No. Let us come here. Okay. We are going to say x squared plus 2x plus 1 plus y squared plus 4y plus 4. I said -1 and -4. We transpose them to their best friend, which is 11, equals to 11 plus 1 plus 4. Okay. Then let us factorize for our variable x. We say we are going to open 2 brackets. Okay. We say what are the factors of x squared, that when you multiply them, they are going to give you x squared. It is going to be x and x. We say we go to the last term. What will be the factors of 1, that when I multiply them, they'll give me 1. It will be 1 and 1. Then from there, we need to determine the signs now. We say, okay, 1 multiplied by 1, it will give me 1. All right. But to give me 2, that 2, which is the coefficient of the middle term, how the signs are going to be is going to be +1 and +1. And see lovely things now that we have 2 identical brackets. We come to y now. We are going to say plus. What are we going to do? We are going to open 2 brackets. What are the factors of y squared? It will be y and y. We go to the last term, which is 4. What are the factors of 4? That when I multiply them, they are going to give me 4. But I add or subtract them, they are going to still give me 4. It is going to be 2 and 2. Okay, 2 multiplied by 2 gives me the last term, which is 4. But to get 4y, how are the signs? Which signs should we have? It must be positive and positive, because positive 2 plus positive 2 give us 4y. And look, we are having 2 identical brackets. That's where we want ourselves to be. Then on our right hand side, we have what? We have 11 plus 1 give us what? 12. 12 plus 4 give us what? Give us 16. 16, it is our what? It is our r squared, not our radius. Look now, we are having what? 2 identical brackets. What can we do? Write 1 identical bracket, but to the what? To the power of 2. Don't forget that what? That exponent 2. We do the same. We are having 2 identical brackets. We write 1 is going to be y plus 2 close bracket to the exponent of 2 equals to 16. And then from here, we can determine the coordinates of the center as well as the length of the what? Of the radius. It means now the coordinates of the center. The coordinates of the center will be what? Will be -1 and will be what? -2. Then our r squared, not our radius, it is 16. To get our radius r, we are going to apply the square root both sides. Remembering that in mathematics, when you have an equation, what you do on the left, you must also do on the what? On the right hand side. So what is going to happen? The square root is going to kill each other, which the exponent 2 until both of them dies. Then we are left with what? With r equals to the square root of 16. That will give us what? That will give us 4. That will give us 4, and then we are going to have forward 4 units. There we are. So it is very important that we do what in class Banabaga. We listen and we practice. We practice how consistently, and we'll have what? We'll get our what? We'll get our results. We need to be consistent when we do what? When we do what? We need to be consistent when we practice, and we need to be consistent in listening and learning. Then we'll see that mathematics, we are going to excel in it. Thank you. Let us move forward. Okay. In terms of the equation of a circle, already I have touched to it, but going through our slide, what is happening? The equation of a circle, what is the standard form of the equation of a circle? It is open bracket x minus a close bracket to the exponent of 2 plus open bracket y minus b close bracket to the exponent of 2 equals to r squared. Then they say where a is the x coordinate of the circle center, b it is the y coordinate of the circle center, then r it is the length of the circle's radius. Then they say if a and b are equals to 0, the circle is centered at the origin, and the equation reduces to what? To x squared plus y squared equals to r squared. Already, that part already I have what? I have touched. Okay. We are not going to do every example for the sake of time, because let's see now. Okay. Time is not on our side, so we need to push. So we are not going to do every example. Okay. But we are going to address and understand the concept. Okay. Even tomorrow, when you get a question paper, when you write, you know the concept. This is the right way to approach, or ways to approach it. Okay. Example 4, our example, finding the equation of a word, of a circle. They say, write down the equation of the circle with the center negative 1 and 3 and the radius 2 and 2 square root of 3. Okay, let us look for A. Number one, we need to know the standard form of what? The equation of a what? Of a circle. The standard form is what? It is x minus a. We are going to have open bracket y minus b, close bracket, to the exponent of 2 equals to r squared. Then what are we given? We are given the center, point center. And point center more, what is happening? We are having the coordinates of the center, which is -1 and 3. What is A? A is the x coordinate of the circle center. What is B? B, it is the y coordinate of the circle center. So we are going to substitute. When we substitute, we are going to say what? Open bracket. We are going to have x minus, we are having minus, then we are having the x coordinate of the center. The x coordinate of the center is not 1, but it's -1. So that 1 must come with its own negative. Don't make a mistake and then you put a 1. Don't do bad things. It is -1. So we are going to do what? Put -1. Close bracket to the exponent of 2. Plus, open bracket, y minus, what is the value of b? Already in our equation standard form, we have a minus between y and b. But what is the y coordinate of the center? It is +3. So Yona does not have a stress. It comes with close bracket to the exponent of 2 equals 2. Then what is 2 square root of 3? 2 square root of 3 is not r squared. 2 square root of 3 is not r squared, but it is what? Radius. Radius, which is what? R. So our radius, how are we going to substitute it? We are going to say open bracket 2 square root of 3 close bracket to the exponent of 2. Then we simplify. Therefore, our answer is going to be what? X negative by -1. We are going to have a positive. Positive what? +1 close bracket to the exponent of 2 plus open bracket y minus 3. Sorry. We are going to have y minus 3 close bracket to the exponent of 2 equals to, then you simplify. Then when you simplify, open bracket 2 square root of 3 close bracket to the exponent of 2, then our answer is going to be 12, because 2 to the exponent of 2 is 4, then square root to the exponent of 2, they cancel, is 3. 3 multiplied by 4 is going to give us 12. Therefore, this will be the equation of a what? This will be the equation of a circle. That's what we need to know. Okay, thank you. Then many examples. Let us move. Tangent to a what? To circles. Tangents to a circles. What is a tangent? Yes, we know that a tangent, it is a straight line. A tangent, it is a straight line, no problem. But in going deep, what is a tangent? A tangent is a straight line which touches a graph. In this case, a circle. Our graph in this case will be a circle at 1 point only. At 1 point only. I repeat again, a tangent is a straight line which touches a graph. In this case, our graph will be the what? The circle. So where does it touches a circle? It touches a circle at 1 point only. Then a secant. What is a secant? Is a straight line which cuts a circle at 2 distinct points. At 2 distinct points. An important principle from Euclidean geometry is that the radius is perpendicular to the what? To the tangent. A radius, it is perpendicular to the what? To the tangent. And if I remember very well, it will have to be out of our 9 theorems that we have learned in grade 11. That will be theorem 7. That say a line drawn from the center of a circle to the circumference of a circle will be perpendicular to a tangent. A line drawn from the center of a circle to the circumference of a circle at a point of contact, it will be perpendicular to the what? To the tangent. Okay, moving forward, we say straight lines and tangent to the circle. We have explained. Okay, a tangent to a circle is always perpendicular to the radius at a point of contact. At a point of contact, it is where they meet. It is where they meet. So at a point of contact where they meet, they form an angle of 90 degrees. They form an angle of 90 degrees, right angle. Okay, we say the steps to finding the equation of a tangent to a circle. When the point of contact is given, how do we do so? We find the gradient of a radius at the given point of contact. Number 2, you use the gradient of a radius to find the gradient of a tangent. Then you use this lovely property that says the gradient of a radius multiplied by the gradient of a tangent will equals to -1. Remember, tangent is perpendicular to the radius at the point of contact. What is a point of contact? Where they meet. Okay. Number 3, use the given point of contact and the gradient of a tangent to work out the equation of a tangent. The last one, use the given point of contact and the gradient of the tangent to work out the equation of the tangent. Okay? Then let us continue. Okay, they say determine the equation of the tangent to a circle. X squared plus y squared equals to 8 at point A. The coordinates of point A will be 2 and 2. Will be 2 and -2. All right. Let me switch here. Our example. Our example, let us look now. Our example 1. Our example 1, it says, determine the equation of a tangent. Determine the equation of a tangent whereby the equation of a circle to the circle where the equation of a circle, it is x squared plus y squared equals to what? 8. Then we are having at what? At point A. What is point A? It is a point of contact. It is a point of contact. At point A, the coordinates of point A, that will be 2 and -2. I want you, my beautiful children, to remember that the moment you have the equation of a circle in a form of x squared plus y squared only, x squared plus y squared, you should know that the coordinates of the center is the origin. The center is at the origin. The center is at the origin. And what will be the center? The coordinates of the center, it will be 0 and 0. Remember, to find the equation of a tangent, we must have the gradient of a tangent. But first, we must be at a point where we first find the gradient of a what? Of a radius. Let's say, okay, this will be our beautiful circle. We'll have our tangent over here. Sorry for it not being accurate. Okay, we are having point A here. Okay, we are having point A. Let's say our point A here, it will be 2 and negative 2. Then let's say now, roughly so, this will be the center. So what do we know about the radius? Okay, sorry. What do we know about the radius? The radius at a point of contact. Okay, let me write it this way. No. Roughly so, let me just do this. Okay. Roughly so, my sketch is not drawn to scale. At a point of contact, let's say this is our center. So what is happening between the radius and the tangent is that they are always perpendicular. What are the coordinates of the center? It will be 0 and 0. That means now, what must we do? Find the gradient of the what? Of the radius. What are we going to do? We say the gradient of the radius will equals to, okay, let's say this is our center O. We'll say the y coordinate of O minus the y coordinate of A divide by the x coordinate of O minus the x coordinate of A. What will be the y coordinate of point O? That will be 0 minus the y coordinate of A is negative 2. Don't make a mistake and then you put positive 2. It comes with its negative, this 2. Divide by the x coordinate of O, it's 0 minus the x coordinate of A is 2 equals to our answer, the gradient of our radius. Negative by negative will give us positive. 0 plus 2, it will be 2. 0 minus 2, that will give us what? Negative 2. 2 divided by negative 2, that will give us negative 1. Then once we have found the gradient of a radius, where do we go? We go to our property, our lovely property that says the gradient of the radius multiply by the gradient of a tangent, it will equals to negative 1. What is the gradient of our radius? That will be negative 1 multiplied by the gradient of our tangent. It will equals to negative 1. Then we wanted the gradient of our tangent. What are we going to do? We are going to divide by negative 1 both sides. Remembering that in mathematics, when you have an equation, what you do on the left, you must also do on the right for your equation to be balanced. Negative 1 will fight with negative 1 until they cancel each other. But negative 1 divided by negative 1 is positive 1. Multiplied by the gradient of a tangent, it will be the gradient of a tangent. Then equals to positive 1. Then once we have found the gradient of a tangent, we now go and find the equation of a tangent. What is a tangent? Is a straight line. How do we find normal, basic? How do we find the equation of a straight line? We must have a gradient and we must have a point that is on that straight line that we are looking for the equation of it. Is point A part of the tangent? Yes. So we are going to go to what? To y equals to mx plus c. What is our gradient? It will be 1. So we say y equals to, our gradient is positive 1. Let me put it so you see it. Multiply by x plus c. To find the value of c, we are going to use that point. Substitute where we see x and y to find our c. Y will be negative 2 equals to your 1 multiplied by the value of x. It will be 2 plus c. We'll have negative 2 equals to 1 multiplied by 2. It will be 2 plus c. Then we want the value of c, not 2 plus c. So how are we going to get c? We take 2 and transpose. When it gets there, it's going to be negative. 2 minus 2, it will give us what? Negative 4. And our equation will have to be y equals to what? X minus 4. Or those who use the method y minus y1 equals to m open bracket x minus x1. x1 and y1, they represent the coordinates of a point that you are going to substitute. So we are going to have y minus y1, it will be negative 2. Don't make a mistake and put 2. Your 2, the y coordinate of a is negative 2, not positive 2. So it comes with its negative. Equals to our gradient is 1. I will write it so you can see it. You don't be surprised, or where did it disappear now? X minus, what is the x coordinate? That will be 2. Then we come on our left, we simplify. Negative by negative, it will give us what? Positive. We'll have y plus 2 equals to 1 multiply our bracket, it will be our bracket x minus 2. Then our equation, we know it must be in the form of y equals to mx plus c, meaning y should be the subject of the formula. Y should be the subject of the formula. So these two disturb us. What are we going to do? Take 2 and transpose it to the other side. Then y will equals to x minus 2. Your 2 on the left was positive. When it goes to the right, it's going to be negative. Then y will equals to x. Negative 2 minus 2, it will give us negative 4. Then that will be your answer. Our answers are the same. So everything is well. So that is the procedure in finding the what? In finding the equation of the tangent. Okay. So with that being said, my beautiful children, time is no longer on our side. So with that being said, I would like to say, as Mr. Mutaung, I would like to take this opportunity to say thank you for being present. Please make sure that you practice. Please make sure that you listen and understand. Then I assure you, mathematics, I assure you, paper 2, analytical geometry, we are going to pass. So with that being said, thank you.